Hi, everyone. Good afternoon, good morning, good afternoon, good evening. So that's what I do. It's always a confusion which to start off. So here I'm going to be talking about the curious case of knowing the unknown before they find you. And I am glad to be speaking at RootCon 15 today. A bit about myself. I am security relations leader at Sneak, and I'm also neck deep into OWASP, which is Open Web Application Security Project, a community for application security and multiple other aspects. I'm on their global board leading two projects and a chapter. I'm also on the review board of some of the conferences in India and around the world. Apart from that, I love bringing in more diverse people into cybersecurity. So I started off with creating awareness in women, and then we thought, why don't we have something for kids? So we started off with infosec kids, and now we've started infosec diversity, so even students and everyone, even the elderly, can join us. That's a bit about myself. Coming back to the presentation, if you look at this picture, and let's take a moment to reflect on this picture, and when you think about this, what comes to your mind? Is it a futuristic outlook of the world, or perhaps the uprising of our robots overloads? That happens. Like, we want automation everywhere. I ask myself, that's interesting. Now, how much of the information does the robot learn about a child, and where is the information stored? Like, I remember these things are getting stored somewhere, right? So are they stored safely? Who knows? I think about this. Where does the robot get its software updates from? And can this stream source be compromised? Can happen. What can happen when it gets compromised? A lot can happen. So, what's the probability that someone hacks in and can watch the video feed? Or maybe talk to your child when you're not around, because they are able to see what's happening in the house. These are some of the things that keep me up at night. Like, I have kids at home, and it scares me. There are a lot of internet connected devices which are at home, and we have to be very cautious about that. Now, if you are in this talk, or if you've joined this talk, that means you care about software. You care about software security. Most of all, you're curious, like I am. I'm always curious about knowing something new. And when the title says curious case of something unknown, so most of all, how does open source software's supply chain security work impact on all of us and the open source components that we use? So about open source, when we talk about the whole environment, we have containerization, we have serverless functions, we have bare bones, we have easy to installs. And if they bundle up open source dependencies, then the risk is there, isn't it? We've seen a lot of breaches in the past. And yes, the use of open source is accelerating. However, with great adoption comes great responsibility and risk. And that's when we say that free and open source is here to stay, we have greater responsibility in that. And the problem is not just that, but using safe base images is also very intuitive. Consider consistently what I have seen in the past few years, year after year, we have seen the top 10 Docker base images on Docker Hub carrying security vulnerabilities in them by default. And the result is Docker images almost always bring down vulnerabilities alongside their value. So it's a big challenge. How do you maintain that? And that's why we need developer first security platform, and that point out the issues in the form of the developers need to understand that. But can we force upon something on anyone? Like, if somebody asks me that you have to do that, I'll be like, I can't do that. Like, it's not possible for me. And that's when the big challenge comes, that how exactly I'm going to be maintaining all of that. And that's how they're showing us how to fix the problem. uh, Now I am thinking, but is there a way that we can educate? Or when we talk about, we no longer need to be security engineers, we just need to be developers. Like, we all need to think from a perspective that we are all empowered and we are going to fix this problem. That means we need to enable each other. That's a big point comes into picture. And apart from that, if we look at the holistic code, the code that makes up an application has changed, totally changed. I've seen a lot of changes in the past. In order to maintain the pace required to complete in a digitally transforming world, application development has changed. 10 to 20% of the code is actually in-house built. But what about the rest of the code? So that's what it is. 80 to 90% of the code is open source in our application. Whatever we say, 80% of the vulnerabilities found are in indirect dependencies. So you have code, then you have third party code, and then there are indirect dependencies which are there. And that's when, if we talk about containers, like, can we leave the containers because they are the major part of any of our application? And that's when we have to look at how exactly we are deploying it. How are we trying to leverage the different ecosystem that we have, because we want everything to be up and running as soon as possible. And think about leveraging the software supply chain itself, which is providing us the competitive edge, digital transformation, which is also changing the risk profile. So often application security teams focus first on security code with tools like SAS, DAST, and as this is the code that their development teams are writing and may be seen as the primary code. But what about the open source code? So open source code quickly becomes the majority of the overall code base, as I said. And if it's the overall code base, how are we going to save it? That's going to be very tricky. And therefore the successful strategy is to focus first around around the information that can help us in getting the information about our third party dependencies. And not just that, think about like the infrastructure as a code that is becoming a big thing, because infrastructure as a code is actually enabling us to do a lot. If I want to enable or spin up any environment in just a blink of an eye, I need to run some scripts and it'll be done. And think about for or during the sale, if I want to spin up an instance, or maybe multiple instances if there's a load which goes high, these infrastructure as code scripts do help a lot. That's just one example, but they are helping us big way. But let's rewind back in time to get an early glimpse of how a developer perceive the risk of open source software. If I go about in an environment wherein in 1984, the Turing Award winning Ken Thompson wrote a short essay which titled Reflections on Trusting Trust. Like, if I talk about my own assumptions, I always say zero trust, which is never trust, always verify. But in his article, what he did, he actually describes how he added a backdoor to the login program, and then he continued and added a backdoor to the C compiler. And then he further continued this chain of attacks by backdooring the compiler that compiles the compiler. So it's like a chaining of it. And that was way back in 1984. But now also we are seeing this kind of attacks. How tricky that could be, how crazy that is. Now we have seen all of this from the past so many years, but still we are again becoming part of the malware distribution vehicles. As we learned by Thompson's Trojan horse story dated back in 1984, developers have been targeted as a vehicle to distribute malware and backdoors for a long time now. And let's explore some recent events. Now, if I talk about in 2018, the JavaScript ecosystem witnessed its first high impact spearheaded surgical attack targeting maintainers and developers working in open source ecosystem, and themselves being used as an attack vehicle to distribute malware or malicious JavaScript code designed to decrypt itself. Oh my God, I just think of it and it feels like, what is happening? Like, what's going on around it? And this was very well known event stream incident. And if I talk about, like, furthermore, the event stream existed on the npm JavaScript registry since 2011 and practically did not receive any new releases in the last 2 years, but gained millions of downloads per week. and you can see the stats which is happening. And out of the blue, a person shows up on the GitHub repository, opening an issue and wanted to help as it's customary and open source code. And they further contribute code with several pull requests. Then they also create a pull request that adds a dependency into event stream own package dependency. Oh, that sounds fishy. Now, if I go back uh, from that place to now, an academic research paper published in 2019 investigated the properties of language-based software ecosystems. And trust me, it's huge. It's huge. Every other day, somebody is coming up with something new, and found that 61% of open source packages on NPM could be considered abandoned because they did not receive any release in the prior 12 months. And sometimes, if somebody out of the blue comes and says, I want to help, and instead of helping, there's something malicious that goes inside it, and somebody might have it as part of their code. Because we have seen cases wherein I have a code, there are files which I'm not using, but they're still staying in my code. Why so? They shouldn't be staying. And that's when the state of open source security comes into picture, that how much do we know about the current state of open source security and what it entails. And not just about open ecosystem, but about our own environment. I've seen cases wherein organizations don't know about their own environment, and that's very, very critical. And as a case study, we refer to the marked own security vulnerability from several years back. So marked is a markdown parser for the web download, which downloaded millions of times a week. And one of the most popular libraries for this purpose is the JavaScript and Node.js ecosystem. But one day, a security researcher opened a pull request which reports and fixes XSS vulnerability, including tests for future code regressions as well as proof of code examples. Now, as this is open source software, maintainers are really just trying to do their best, but they just can't be there all the time. And there are no legal or contractual obligations for them to support you, right? Because we all, when we talk about contributing to open source, we give our best and spare our free time and valuable time in that. So this vulnerability was left out in the open and no fix for a year. For an year. And if you go back, like a couple of years back, what happened to Apache? For a couple of months, the vulnerability was left. And what happened? A huge breach. And everybody was just talking about it. So the security issues and proposed code fixes, which might have opened long back, but people were not checking it every day. Now, if I talk about compromising the maintainer's account, and when we are all so much dependent on open source software, we can't ignore the question of where we put the trust and what are our mitigations and security controls to cope up with the risks involved. And in 2017, a security researcher working with the Node.js Foundation conducted a research in which he wanted to assess the state of weak NPM credentials used by the maintainers. His work revealed the devastating truth of developers' lack of security hygiene. And not just them. Trust me, security people sometimes misses out on a lot of things. And so a security researcher was able to gain published access to 14% of the NPM or NPM.js ecosystem modules. That's huge. And some of these modules are downloaded tens of millions of times a week. Like that's a huge number and are an essential and key part of the thriving JavaScript ecosystem. The problem was rooted with insecure passwords chosen by well-known maintainers' account, and such as literally the word password. Think about passwords are like your toothbrushes. Do you share your toothbrush with anyone ever? No, never ever. So why do you share your password? That's one key aspect. And as a cybersecurity expert, Bruce Schneiser said in his book Secrets and Lies, humans often represent the weakest link in the ecosystem or in the chain. Now, when that happens, how much thought are we giving in the security of our own development infrastructure? Resources like the cloud instances, staging environments, or the build and continuous integration tooling. How often are we updating them? Think about Visual Studio Code. In January 2021, a security researcher broke into Microsoft Visual Studio Code GitHub repository, essentially providing him or the capabilities of making code modifications. Ah, that sounds interesting. To the popular and very, very well-known IDE that many developers use, and not just them. We also use it. Like I use it in and out. Uh, and when I talk about the downloads, according to Statistica, there are about 24 million developers worldwide. And that's just the tentative number I'm telling you. But if they are downloading Visual Studio Code with like this active number, what is going to happen if there is a bug that comes in? And diamonds are forever. We have reached a point we take open source software for granted, and that we all have to agree. Whatever we say, we have to do that. And open source registries are open in their nature and allow developers to openly push their package to them. Now we have become accustomed to opening an issue in a project source code repository and then asking for help. Now, asking for a feature, asking to get our bug fixed for us. We import open source libraries to our projects and we treat them as if they're unbreakable and they cannot be broken by anyone. That's where the challenge lies. Hmm. And what happens when the maintainers remove their dependencies out of the registries? This is exactly the story of what happened in 2016 when a maintainer named Azir pulled tens of his open source packages from npm.js. One of them was a very pivotal package in the ecosystem, and failing to download it now resulted in a widespread breakage of CIs and install processes. Oh God, that was very, very tricky. And that's when, at the very least, this incident showed us two things. The weakness is in how businesses fail to manage their open source software and expose their soft spot. And next one is how registries did not foresee this as a problem. And so were designed or were not designed to handle these circumstances. So how do you handle them? Like one, there is a malicious thing which is going on. And then other, if maintainer leaves or removes those packages. How about what kind of malicious activities and assets which can be tracked back to the open source ecosystem, right? That's very, very tricky. And time after time, we find more and more malicious package hitting the npm JS ecosystem, and not just npm JS ecosystem, but other ecosystems as well. But with npm JS, we could actually find out the recent statistics. And if you accidentally install one of these by a typo squaring mistake or by someone planting one of these in a nested dependency tree, your chance of finding it is basically zero. Then what would you do? And malicious packages are not just a thing on the JavaScript ecosystem. On March 2021, more than 3,000 malicious packages were published on PyPy registry. What will you do then? Like everywhere this is happening. And to further show to actually give us limelight how attackers can harness open source software to their advantage, Alex Birson published his research in February 21 about how he exploited design flaws in package managers, registries, and design and human error to infiltrate into corporation like Apple, Microsoft, and many others. So these are small things which become so big that even we don't get to know. Now, when that happens, are we going to use these softwares more or less? I would like to leave you with the following questions to ponder them. And are we going to have like more or less of softwares? I can feel that it's going to be more. And are we going to trust someone? Are we going to have trust based on all of these softwares, dependencies, and which are being used in our robotic systems as well? That's going to be very, very tricky. And oh, looks like we missed something. So what happens is developers often think about security of their app in terms of vulnerabilities that lay in the open source dependencies. But there's a lot of things which are missed. Now, let me show you something which actually, oh, I don't have to show, but I have to give a demo. Let's go ahead and see that. Okay, so that's my browser. I'm going to go into my dev environment. Hmm, I'm using Visual Studio Code, interestingly, right? And we were talking about Visual Studio Code about a lot. So here I have a Visual Studio Code, which has some of the vulnerable libraries, and I have a website running. So I have my ngrok running, and my website is infosecvandana.ngrok.io. And if you go to my website, it's actually infosecvandana.com. And if you know me, you'll actually traverse through my website, or even anyone who you know, you'll just go ahead and try and check out them. So what happens next? Maybe must be something. Now, if I tell you from a perspective wherein this is an attacker perspective, I have set up everything possible. I have set up my system. I have set up my Visual Studio Code. My website is running. Now, think from a perspective of a normal developer. Now, what happens is developer is using Visual Studio Code like I'm using here. And as part of extensions, there are a lot of extensions that are there. Now, I use instant markdown a lot. Like I'm a huge fan of markdown. So I'm going to check what happens to instant markdown. Instant mark. Okay, it's here. So if you look at the screen, instant markdown says version 1.4.6. Interestingly, that's fine, but there is an updated version which is there, 1.4.7. Now, I have not updated. I am a developer and I'm like, give me some time. I will update. Like I don't update as soon as the update comes. That's fine. But what's next is that this version is vulnerable. What information can I get? So there are some files which are there in the user home directory, and anyone, if let's say I'll go to my command shell. So this is a developer's ecosystem. And here I'll go ahead and do ls. And if you see that there are files which I have saved here in the home directory, which a lot of people do, and especially keys and all, they do save it. And I've seen it personally. So here I have actually saved a passwords file. It could be any other file also. It could be key file also, which I want, which attacker might want. So now let's see what is there in the passwords file. Oh, how scary is this? You've been hacked. It could be passwords also, but it is not. So let me do one thing. Now, as a developer, I will visit a malicious website. And before visiting a malicious website, let me show you. I have like just the simple code and that's all. Now, the malicious website is infosecvandana.ngrok.io. I'll copy that. Okay, I'll just copy it here. So just for your kind information, it's just running locally, which I stops after every demo. So you wouldn't be able to do a lot of stuff. Okay, yeah, I'm going to go to my browser. I'm going to type ngrok.io. Okay, something interesting which is happening. While it's loading, I'm going to go back and see what exactly is there. Hmm. Okay, my instant markdown is running. Now, if you see here, oh, it's just a normal website, but it says you've been hacked. How can I be hacked? Let me refresh. Interestingly, what is it coming? Now I'm coming back to my system. Oh, if you see that there are two files, what it says, how it's scary, you've been hacked. Think about, as an attacker, I'm running running a server which is getting all these files from the home system or home directory. Now it could be any other juicy information as well, which can lead to many more critical things. And that can create a lot of issues for a developer, for organizations. And this is just the basic extension that we use in the Visual Studio Code, but that could be anything else also. Now, coming back to my presentation, let's go back to the presentation. Here, dev environments are very, very important and critical. Earlier, we never used to think about those environments, or maybe not giving much of the heeds, but now the way these are getting used too much, there are vulnerabilities which are also coming up, which needs to be fixed and these softwares needs to be updated. And extensions power an ecosystem for those developers. We can see them. And of course, many of these are built with the open source vulnerabilities that weave just between them. And talking about this could be anything. Talk about latex workshop, instant markdown, rainbow fort, open and default browsers. So what could go wrong and what could happen? Now, if I talk about like what could be the takeaway from all of this, be aware of what you install in your dev environment. I've seen cases wherein there is an application library or infrastructure application library or a kind of a CMDB, which is there, but it is never updated. What I download, I never document it, and nobody ever gets to know. And when something happens, then they realize, oh, this is there in our environment. And that creates a lot of issues. Now, what can help us? Always be scanning. It is very, very important to scan our ecosystem. There are a lot of tools, technologies from open source to commercial tools which are available. So it's very, very important to understand our own appetite ecosystem. And if you don't do it, nobody can save us. And if we are using source code to containers, to infrastructure and whatnot, it is just going to be very, very tricky. Now, I, when we are talking about all of this, and if you remember that I talked about indirect dependencies, you fix a vulnerability in one of the dependencies, but there is an indirect dependency in the application code. What you need to do is you need to understand that as well and fix that as well. Even if one library is vulnerable, that means your code is vulnerable. I just was able to pick up the password file from a normal system, but I could find any other information as well. I might be able to take over those accounts and whatnot. So if we don't have the updated ecosystem, it's like we are not knowing our own house. So how are we going to save it from the thieves? We can't. We would never be able to do. And that's when we need to maintain a cordial relationship between the developers and the security teams. And it's both of their responsibility. And now when the ecosystem is growing to the cloud, to IoT, to whatnot, so it becomes even more important to understand those side of the wheels as well, and then only run the car. If we don't know it, it's going to get punctured anytime, and we wouldn't be able to fix it if it's on the road. And there's a lot of hampering that could go in, and a lot of issues that can arise. I've seen it personally. Now, I'll tell you one example wherein there was one time wherein there was a vulnerability which was a medium level vulnerability for which we thought, okay, we'll take 15 days and we'll get it fixed. And that was fine. But then there was some code change happened, and due to which it became a high severity vulnerability. Now, I had a good relationship with the teams who were working on those environments. They came back and said that there are some changes which have happened. Can we go ahead and test them again? And can we figure out that what could have changed in the environment? And we realized that medium vulnerability became a critical one. And that's when we could fix it on time, or the things could have gone in a very total different direction. So knowing the ecosystem before somebody else get to know about us could be very tricky, could be tricky, as well as could also save us from all the damages which could happen. And one point to say here, that is around supply chain security. Supply chain security uh, is not new. We've seen those cases arising big time recently, but that's not new. So we need to have some kind of an environment when we can maintain the SBOM, which is software bill of materials, around security of supply chain, and fix them before even somebody tries and hamper those things. So now, while I'm concluding, so I'm part of Sneak. So here Sneak is coming up with SneakCon, which is an open source thing which you can join in October. And that's the major thing. Use your superpowers, and especially not just for the developers, but for security people, because we all are sailing in the same boat. Let's use our superpower. And what we can do is we can only leverage it to build something good. and be excellent to each other. We always know that security community is the most amazing community wherein we all share information. And that's why we are growing big time and people are getting fascinated about our community. So be good to each other, share knowledge, be supportive, and let's not say anything bad about any of those languages, but just be contributive in updating them. I am so glad to be here to be talking about the curious cases of knowing the unknown, like third party dependencies, which are big time used in every environment, right? And if you have any inputs around it, if you feel there's something more that I could have added to it, please do feel free to share. And remember that we are all here and we need to hack the world, but still at the same time, we need to secure it. Thank you so much for listening to me. It was wonderful to be here. And let's hack the planet.